Hi all, this is Vijay Patil, Assistant Professor, Department of Mechanical Engineering, Vivekananda College of Engineering Technology, Puttur. In the previous video, we have discussed about what is measurement and why the measurement is needed and what are the importance of measurements and where it is applicable in research, in defense systems, in industry, in laboratories, day-to-day life. So measurement plays a very important role, and some of the important definitions of measurements we have seen, and what are the standards in measurement, like primary standard, secondary standard, ternary standards, and working standards. And we have discussed some important aspects like what is calibration, what are the types of errors occurring in a measurement, how to measure the errors, and accuracy, precision, and these aspects we have seen. Let us study some of the important aspects like true value and actual value. What is true value? What do you mean by true value? How you can measure the true value? True value or actual value is nothing but it's the actual magnitude of an input signal. See, whatever the measurement is to be done, that means whatever the input we are going to give to the instrument. Suppose if you put a 1 kg of stone on a weighing machine, it should give a 1 kg only. So that means whatever the input signal is there, that should be processed properly and it should give the correct output, like the same quantity to be measured. So that is nothing but actual value. The value indicated by instrument is uh, correlating to the input signal. So that is nothing but actual value or a true value. Again, the true value or actual value is infinite number of measured value. That means it's going to take the average of all the infinite number of measuring values, and it is going to take average and it's going to give the correct output. That is nothing but true value or actual value. The second thing, indicated value. What do you mean by indicated value? Whatever the signal is processed, it is going to give the output at the end. That is nothing but value indicated by a particular instrument. The magnitude of input signal indicated by a measuring instrument, that is nothing but indicated value. That means input signal is processed properly and it is going to give the value of that particular measuring quantity. That is nothing but indicated value. Then coming to the result in the simple sense, whatever the input is there, and that has to be sophisticatedly processed, and then it is going to give the output of the particular measuring quantity. That is nothing but result, and result is given by VR, the term called as a VR. It is given by A into Vi plus P, where A and B are the multiplying and additive constants, and Vi is the indicated value. Next we will see what is a correction. Suppose there is a actual value of the measuring quantity is there, and indicated value of that quantity is there. So if there is any difference is there, then definitely there will be a error. Error may be caused due to some human negligence, or it may be due to internal disturbances present in the measuring device, or it may be due to some vibrations. So many aspects are there. So due to that error, the actual value what you are going to get at the end is not correlating with the input quantity. Then there will be correction needed for that one. So basically, what is correction? It's a revision applied to the indicated value which improves the worthiness of the result. That means in order to get the precise results, we have to correct the instrument. So for that one, we have to apply the indicated value which improves. That means revision of indicated value. That means whatever the input quantity is there, that has to be processed, right? So the revision to be applied to the indicated value, that means whatever the output you are going to get, that has to be revised properly several times. So then the output is going to improve. That is nothing but the correction. Correction is done by calibrating the instrument, or the correct input methods. By following the correct input methods, we can avoid the errors and we are going to get the correct results. And coming to the discrepancy is nothing but it is the difference between indicated values or results determined by a supposedly fixed true value. That is nothing but, suppose there is any error is there in the instrument, then there is a difference in the indicated value or results determined by a particular instrument. Then we are not going to get the true values. So then there is a discrepancy coming to picture. Next, coming to the error, as I told, error is nothing but it is a difference between the true value and result. That means whatever the true value of the particular quantity is there, that is going to differ from the actual output what we got at the end. That means result is the difference between true value and result what you are going to get. That is nothing but error. So previous video we have discussed already what is accuracy. Accuracy is nothing but accuracy of a measurement determines how close the measurement comes to the true value. Therefore, it indicates correctness of the measured value. That means accuracy named whatever the measured values are there, how closely they are associated. That determines the accuracy of the particular measured quantity. And coming to the precision is nothing but closeness of two or more measurement to each other. That means if you measure quantity one time and second time, third time, that means so whatever the output you are going to get, they are closely associated. That means the output is closer to the actual value or a true value. That is nothing but precision. And the good precision simply tells how well a series of measurements cluster around the average value. That means the whatever the output you are going to get for several times by inputting the input quantity, every time you are going to get the correct value. The output values are closely associated. That tells how well the measuring instrument is correct and whether it is having some errors or not. That can be determined by the precision quantity. So in the figure we can figure out, if you look at the first figure, second figure, third and fourth, the first figure depicts the measured values are accurate and precise. Second, you can see the measured values are accurate but not precise. Third, we can figure out the measured values are precise but they are not accurate. And the fourth figure says they are not accurate and not precise. That means all the values are randomly placed. You are not going to get the correct output several times. And coming to the resolution, what do you mean by resolution? Why it is needed? See, if you want to measure any screw thread and all, or if you want to measure the small gear teeth, if you want to measure the flank, if you want to measure the module, if you want to measure the inclination angle between the two teeth or two screw teeth, so at that time resolution comes into picture. Resolution is basically it's the smallest increment of input signal that measuring instrument is capable of detecting and displaying. That means so we have to have a high resolution measuring instrument in order to get the clear view of the component, where we are going to measure several parameters like its different quantities like angle, breadth, thickness. If you go to the teeth, gear teeth, so there we are going to measure the module pitch, thickness and flank angle. So everything we are going to measure. So in order to measure that one, we have sophisticated resolution system and suitable displaying system. Resolution is nothing but it is the smallest increment of an input signal. That means whatever the input signal is there, that we are going to magnify it. So to get correct displaying. So that is nothing but resolution. And threshold. Why threshold plays a very important role? If the instrument input is increased very gradually from a zero, there will be some minimum value below which no input value can be detected. So then threshold comes into a picture. The minimum value defines the threshold of the instrument. That means whatever that minimum value to be measured, that threshold capacity is to be given to the instrument in order to get the threshold of particular measuring quantity to be done. And minimum value of input signal that is required to start from zero. That means threshold value in the sense the minimum value to be measured. That means the minimum value or a smallest quantity that has to be measured. That means it should start from zero and up to the maximum whatever the value is to be measured, that comes into the threshold. So that means if you go for a micrometer handle, so micrometer is having the least count of 0.01 mm. That means so that smallest value is measured by that particular instrument. If you take a vernier caliper, its the least value that can be measured is 0.02 mm. So that means, so it will start from 0, and it can measure the smallest value of a particular quantity. That is nothing but threshold. Sensitivity, uh, nothing but it is a how the instrument is sensitive, how much it is sensitive. That means any variations or any disturbance is there, it may be due to internal disturbance or external disturbance, so that has to be detected by the instrument. That is nothing but sensitivity. Sensitivity, basically it is a ratio of change in the output signal and change in the input signal. Why the output signal is going to change? Again, due to the some vibrations or external disturbances, or if the instrument is not calibrated properly, or if it is not maintained properly, then errors are coming to picture. Due to that one, the system is not going to give the correct output. So sensitivity, the sensitivity, it is a ratio of output signal to the change in the input signal. So every instrument should have a highest sensitivity. That means wherever the changes are there due to the external environment or internal disturbances, that has to be sensed properly. Next, repeatability. Repeatability is nothing but, if you see the graph of output versus input, that means if you see the linearity curve, all the values are placed properly. That means they are closer to each other. That means if you are going to measure the input quantity over several times, then you are going to get the same output for all the times. That is nothing but a repeatability of an instrument. That means every time it is going to give the correct output. That is nothing but repeatability. If any error is there, that is nothing but repeatability error. Hysteresis. Hysteresis is a very important term. If you are going to test an quantity or any component in an instrument, then you are going to measure some quantities over several times. That means you are going to measure the same quantity repeated times. It is often seen that the input and output graphs do not coincide continuously. So then whatever the input you are going to give over several times, the output is not correct. That means same output you are not getting. That input and output are not coinciding. They are continuously ascending or continuously descending. That means once if you are inputting the values over several input of time, the output you are going to get is ascending one time, or it may be descending. That means the output values are incremental or it is decremental. So at that time you are going to get the ascending and descending curve. So the output and input values are not coinciding, then this phenomenon can be called as a hysteresis or a hysteresis loop. So in the figure you can see the input and output values. Sometimes it is ascending and sometimes it is descending. Basically, what causes the hysteresis effect? Maybe due to the internal friction or sliding or external friction, the hysteresis come into picture. Sometimes the looseness of mechanism or a free play over a long usage of time, the two mechanisms or two mating parts are not maintained properly due to the wear and tear. There will be a free play or a looseness of the mechanism. So at that time, hysteresis come into picture. Hysteresis effects are best eliminated by taking readings corresponding to ascending and descending values of input, then taking the arithmetic average. So, now to avoid the hysteresis loop or hysteresis effects. So once we have to take the readings for ascending manner, that means higherly you are going to increment the input signal. Then again you are going to take descending values, that means from higher to lower. That input you are going to give and you are going to get the output. And finally, those ascending and descending outputs are arithmetically made average. Then we can avoid the hysteresis effect in the particular measurement. Linearity is nothing but the, if you see the actual distance and measured distance, if you are going to measure some distance, if you take a graph of actual distance and measured distance, all the values are linearly placed, and that means they are going to draw a linear curve. That means ability of a test to give results that are directly proportional to changes in the concentration of the substance under analysis. That means the test results obtained, that is directly proportional to the changes in the concentration of substance. If you are going to take the distance, that means whatever the changes are there, that are linearly placed. That means all the values we are going to get at the output, they are linearly placed. That is going to give a linearity. Suppose if you are going to measure one length of a particular substance, so it may be independent linearity or it may be a proportional linearity. That means independent or if the output just remains within a full scale output without being proportional to it, then it is called as a independent linearity. Suppose if the output remains proportional to the full scale output, then it's called as a proportional linearity. That means within a full scale, if the output remains and without being proportional to it, that means it is not proportional to it, whatever the full scale limit is there, then it's called as independent. Proportional means the output remains proportional to the full scale output. That means whatever the magnifying scale is there, full scale is there, that is proportional to the measured quantity. That is nothing but proportional linearity. So these are the figures that will depict the independent and proportional linearities. And what is drift? One more important term, drift. Drift usually causes the measurement results to vary for a given input quantity. That means the measurement value is what we have measured, that will drift. That means that is changing every time. That means you are not going to get the same output over a several period of time. That is nothing but a drift from a actual measured value. So it occurs due to wear and tear of the frictions between the two mating parts, or it may be due to hysteresis effect. That means in the metals usually there will be output whatever going to get, it may be ascending or descending. Due to that one, hysteresis will come into picture, or due to contamination or other causes of environmental factors, it may be wear and tear, corrosion, it may be external disturbances. Due to that one, drift of the measured quantity is done. So thus drift is undesirable quantity, and it occurs very slowly. That means if you bought a new measuring instrument or a new mechanism, if you are going to get a correct output over a long usage of time, due to wear and tear, if it is not lubricated properly, or if it is not serviced properly, if it is not maintained, then there will be wear and tear of the two mating parts. At that time, you are going to get the drifted values. That means output values what we have measured, they are going to vary from the true value or actual value. And drift can be guided by care, prevention, as inspection and maintenance. So whatever the instrument or whatever the equipment, mechanical equipment is there, that has to be maintained, serviced regularly in order to avoid the drifting parameter. Calibration we have already studied. It is a correctness that is to be induced in the instrument. That means correctness means whatever the errors are there, that means if you are going to get the error, that means the difference between the input and output values, at that time correction to be done to the instrument. That is nothing but calibration. How the calibration is done? Calibration is done by comparing with a standard one. That means there will be a standard measuring instrument. To taking that as a reference, we are going to correct the measuring instrument to be calibrated. And again, what is goal? Goal is minimize any measurement uncertainty by ensuring the accuracy of a test equipment and control and minimizer. So primary, the goal term in the measurement is very important. So every instrument what we are going to design, so that has to serve the purpose of minimize the errors, and it should give a correct output. It is to be it is able to give the accurate and precise readings over a long period.